Sometimes, in place of calling distance time graph, it appears to be more correct to call it position time graph. For example, we did one problem in the last class, that A, B and C problem. You will see that in that graph, when time is 0, then there is some distance for A and there is some distance for C also. When time is 0, there is some distance for A and there is some distance for C also. This can create some confusion also, that if there is no time elapsed, how can anybody travel any distance? You can't travel distances in 0 time. The moment you start calling it position time graph, this confusion simply dissolves. If I say that when stopwatch was pressed, stopwatch is a watch, when pressed it says 0 time. Suppose 3 persons are running in a race. Let's say Mr. X is a young man and Mr. Y is an old man and Z is a young kid. Now, it will be unfair to have a race among these 3 people, a young man, young healthy man, an old man and a young kid. So to make it fair, the organizer of the race decides that the old man will be given some advanced position to start off, and likewise the young kid will be given some advanced position to start off. But the young man will have to start from the very beginning, and whoever reaches this point wins. Now it becomes more fair. Now when we are plotting position time graph, and then we are saying that at t equal to 0, y was here, or z was here, x was here, it makes perfect sense. And then maybe x overtook whatever happens later on. But this makes a lot of sense the moment you start calling it position time graph. Now that problem doesn't arise, that when the time is 0, how can y travel distance? Y has actually not traveled distance. Y is given an advanced slot because possibly due to some weakness or whatever, or to make the race more fair. When you are given position time graph, even then you can handle the situation rather easily. Now suppose after some time y reaches here, after some time, then how much distance has y covered? This much distance. That is the distance. This will be called the distance, and when y reaches here, this won't be called the distance traveled by y. No, y did not start from here. So how can this be the distance traveled by y? Y started from here. So this is the distance traveled by y. So sometimes in your, class 9 books, there can be some confusion because of this distance time and position time thing. But I hope this, what I'm saying now, will clear some confusion from those things. And when we talk about position time graph, then it gives us some extra capability. Often we talk about x-axis and y-axis. And our observer is here. Now suppose I want to say that the object is at -2. I can never say -2 distance. -2 distance is wrong. But I can say location is -2. So while it is correct to say the position is -2, it is incorrect to say distance is -2. So position word gives you some extra capability than the word distance. Any questions about this? Let me know. When somebody travels, distance only increases. Even if you change your direction, how can distance decrease if you are traveling? Distance can never decrease if you are traveling. But your position can become plus minus plus minus. Say for example, somebody starts from home or O, goes to the right side, X positive direction is the right side. Say reaches +2 points, turns to the left, reaches home, goes in opposite direction, maybe reaches -5. Again turns to the right. Right? So position can swing from positive, negative, and so on. Distance can only increase. So if somebody travels to the right, and then left, and then left, and then right, distance traveled will be 2 plus 2 plus 4 plus 5 plus 5. So distance traveled is 14, and it will only increase with time. Yes, somebody can stand, take some rest, but otherwise distance will only increase with time. But position can be plus minus. It all depends how that person is traveling. Plus minus 0, it can change, fluctuate with time every now and then. So when you learn about distance time graph, just keep an eye on position time graph also. As far as your scope is concerned, probably you won't have to worry about plus minus sign change for position. But at least this case is something that you need to understand very well. What is the meaning of these three things? Just like we did that problem. I think that problem makes more sense if we use the language position time rather than distance time. So in that there was no plus minus, but had it been position time, it would have been more clear rather than distance time. So if it's a straight line, distance time or position time. We will talk about motion in one line in one direction. Straight line, It's a uniform speed. Non-uniform speed, it will be some non-linear behavior. And a very common example is parabolic, when speed is changing. This parabolic is when acceleration is constant. But if acceleration is also not constant, then it can be very complicated. In this type of case, if you want to know the speed, just take 2 points. Take any time interval. Say this is time t1, this is time t2. In this time interval t2 minus t1, find out how much distance somebody has covered. That distance divided by the time interval t2 minus t1 will be the speed. In this case, you will have to resort to average speed. So if you do the same exercise here, in this case, then that obviously will be the average speed. Once you learn some advanced mathematics, then it is possible to find speed even in these types of cases. But that is beyond our scope of discussion right now. So for such cases, we can find average speed. Again the same story, t1 and t2. In t2 minus t1 interval, when we say time is t1, stopwatch is showing time t1. When we say time is t2, stopwatch is showing time is t2. And stopwatch is pressed right here when the motion began. Let's now talk about the speed time graph. Speed time graph. Speed is also the magnitude of velocity. Velocity is a vector. So we can say magnitude of velocity versus time graph also. And if I just call it velocity time graph, then velocity can change direction also, so it can become minus also. It can go towards the minus direction also, velocity time graph. But as long as we are talking about motion in one dimension, one line, on the same direction, even velocity time graph will not be complicated. But otherwise, velocity time graph can be complicated because one can change direction, and velocity has to do with direction also. So if y-axis is negative, then the graph will go towards the lower side also. That's what happens when we generally make a general discussion of velocity time graph at little more advanced level, where motion can be in different direction also. But for our current discussion, for one dimension, on a straight line somebody is moving and direction is same, no turning involved, then fine. Velocity time graph also will not be complicated. So you can call it velocity time graph also for our current scope. So when we discuss that, velocity time graph, if velocity is constant, well, that is the easiest case you can have. If velocity is constant, uniform motion, then it would be as simple as a straight flat line. Velocity is flat, flat, flat everywhere. If it is 30 kmph, it is 30 kmph everywhere. 30 kmph, 30 kmph, 30, 30, 30, 30. So it's a flat, straight line. There is a use of this graph, by the way. We are talking about constant velocity. So we can write v equal to distance upon time. Let's say this is t2. Stopwatch is showing t2. Stopwatch is showing t1. So distance covered between these two time intervals and time is t2 minus t1. And that means distance is v times t2 minus t1. Now this is something interesting, because if I construct a rectangle like this height is v, this height is v, this height is v, and this is t2 minus t1. Height is v. What is this? V into t2 minus t1. Is it not the area of the rectangle? This is called area under the curve. This is the concept of area under the curve. You know about area of the curve. I mean area of the circle, you know. Area of circle, area of rectangle. This is not area of type of thing. It is just this. Where is the area? For area you need a closed curve. Circle is a closed curve, square is a closed curve, polygon is a closed curve. There is no closeness involved here. So we say area under the curve. For under the curve, we take 2 points and we drop 2 perpendiculars, and then we get a closed figure which includes the curve, which includes the x-axis, and it also includes the 2 verticals. Then this is called, the area of this figure is called area under the curve. You can have straight line, you can have curve, whatever. Say, for example, we have got something like a curve like this, and you want area under the curve between 2 points. Then draw a perpendicular, Basically, perpendicular means parallel to y-axis. Draw lines parallel to y-axis, like that. Then this area, that is what is called area under the curve. Very powerful concept in mathematics and physics both. Actually, it's a mathematical tool using which we solve physics problems. Right now, you don't have to deal with such complicated situations. Right now, you have to deal with a straight line, only straight line, either straight or inclined. I will talk about inclined soon. This is flat. Flat is the easiest. For flat, you get a rectangle. For flat, you get a rectangle. And area of rectangle is this height, which is v, and this thing, which is t2 minus t1. So what is the practical use of finding the area under the curve? The practical use of area under the curve is that it is the distance traveled. It is a distance traveled. Yes, go ahead.
Is it the distance traveled or the displacement?
When we are talking about motion in one direction on a straight line, in one direction, then displacement or distance, they are one and the same. No difference between them. Between the magnitude of displacement and distance, there is no difference in the two. So sometimes I'm calling it speed, sometimes magnitude of velocity. That is fine as long as we are talking about one direction and straight line motion. In fact, calling it one direction alone is enough. When we say one direction, it automatically becomes a straight line. If it is not one direction, then there can be huge difference between distance and displacement. But that's not what we're discussing. Yes, any other clarification or question? So, the moral of story of VT graph is that the area under the curve between the 2 points tells us the distance covered between those 2 points. Now, what if it is not constant velocity? If it is not constant velocity, then acceleration can be constant, uniform, or acceleration can be non-uniform. If acceleration is uniform, then thankfully VT graph continues to be a straight line but inclined. Continues to be a straight line but inclined. This is a case of constant acceleration. This is a case of constant acceleration. If it is not a straight line, well, in that case it would be variable acceleration. Let's not complicate. First, let's talk about constant acceleration. Okay, we have already talked about zero acceleration. This was zero acceleration. This is constant acceleration. Constant non-zero acceleration. Constant non-zero acceleration. Now here, if I want distance traveled between two time intervals, between two time readings of the stopwatch, then the area under the curve that I would need to find would be more complicated. Can you tell me which mathematical shape this is called?
Trapezium.
Trapezium. Trapezium. Perfect. Can you also tell me the formula to find the area of trapezium in case you know it?
Sir, half sum of parallel sides into
Sir, half
height.
Yes, half into sum of parallels
Sir,
multiplied
half
by?
into, in brackets, the parallel side multiplied by height. Multiplied
Height is,
by height.
what is height? What is height? What is height?
Height is velocity.
What is the height of trapezium?
Sir, it's the perpendicular drawn from the one vertex to the other.
Well,
Perpendicular drawn from the one vertex to the other.
well, let's make it simple. It's the distance between the parallel sides. It's the distance between the parallel sides. So, half times sum of the parallel sides, half times sum of parallel sides multiplied by distance between the parallel sides. That's the area of trapezium. But in case you don't know that formula, no problem. We can find area of trapezium by dividing that area into two pieces. One piece is this rectangle and other piece is this triangle. Let me use some alphabets. Let's say this is A, this is D, and this is E. So I want area of this trapezium, which is the distance traveled between these T1 and T2, time readings. Area of triangle is half times base into height DE. Area of rectangle is base AD into height. Okay, I need height also. So I would need maybe one alphabet or maybe one more. One would have been enough, but I'm using BC just so that I can call it ABCD rectangle. So AD multiplied by, let's say, CD. That's it. Now, let's say when time was T1, speed was U. And when time is T2, speed is V. This distance is U and this distance is V. So what is DE? Can you tell me?
V minus U.
V minus U. From here to here it is V. From here to here it is U. So this distance is V minus U. If you are thinking how speed became distance, it's a graph paper. You are taking a graph paper and plotting speed versus time or magnitude of velocity versus time. So whatever you are doing is done on a graph paper. That's how we are able to talk about the distance as U or this distance as V. It's on the graph paper. And what is AD?
So T2 minus T1.
Correct. This is T1. This from here to here is T2. AD is T2 minus T. Now what else? CD. CD is clearly U. Then one more. D is clearly U. That's it. So distance traveled is half times minus T1. That's it. Is V minus U plus T2 minus T1 into U. Okay? Any questions up to this point? Let me know. Now, for the sake of simplicity, let's call this T2 minus T1 equal to T. So UT, I'm writing this first, plus half V minus U into T. Any questions up to this point? Let me know. Now, what is the definition of acceleration? Is it not this? V minus u upon t? That means V minus u is equal to AT. This is a standard result. And when we say V minus u is AT, V equal to u plus AT is also standard result for uniformly accelerated motion, which is what we are discussing right now. This is a uniformly accelerated motion. V equal to u plus AT, S equal to ut plus half AT square. Any questions? Let me know. Generally, when V is upward type, upward rising type, it obviously means acceleration is positive. Whenever it is climbing, it clearly means acceleration is positive. But it may also happen that some particle was at a high speed and then braking starts. Reduces, and finally at some time it becomes zero. Particle comes to halt. So when it's a fall, VT graph is falling is a case of negative acceleration. Negative acceleration. And if we mix two of them, that's very much possible also. You start, you accelerate. You accelerate, you reach some velocity. And then you decide that you would go with constant velocity. That's also possible. You go with some constant velocity. And then you decide that brake should be applied. Here we go. Brakes applied. And one can stop. V0 here. But one can again speed up. So on one straight line itself, such variations are possible. On just one straight line, you're going absolutely straight. Sometimes you go rapidly, sometimes you go with fixed speed, sometimes you decrease it, sometimes you just wait. If you wait, by the way, in that case, suppose this is waiting, it will be 0, 0, 0, 0, and you wait, you have some coffee here in some restaurant, and then you pick up speed again, that way. So there will be some time spent in this activity where there is no motion at all. This is a rest, this interval, taking rest. Flat, absolutely flat and zero. This was flat but not zero. Flat but not zero means constant non-zero velocity. This is zero velocity. The vehicle is parked and somebody is having coffee. So within straight line in one direction itself, there can be several variations possible. And if acceleration is not constant, then this won't be straight line itself. There can be some curve, whatever. We don't need to get into that. So any questions about VT graph? If you have, then let me know. So what's your answer?
Sir, for uniform motion, the line will be a straight line, and non-uniform motion it will have a curve.
Yes. Uniform motion, straight line. Non-uniform motion, it will be curve or non-linear. That's right.
So the motion of that object is that it has uniform acceleration, that's zero acceleration, but non-zero velocity.
Sir, the object doesn't move.
Anybody else?
So the object is at rest.
Anybody else?
Constant velocity.
Constant acceleration. Constant acceleration.
Sir, the object is at rest and doesn't move as time increases.
Okay, some answers are right. I think a couple of them. Distance time graph is a straight line parallel to the time axis. So time is going, going, going. Distance is not changing, not changing, not changing. So object is having coffee, it means taking rest. Distance is not changing. Rest. No motion at all. If distance doesn't change with time, what does it mean? No motion at all. Any questions? Carry on.
Sir, what is constant non-zero acceleration?
Can you repeat?
Sir, constant non-zero acceleration.
If there is constant non-zero acceleration, would not velocity change? Would not distance change in that case? If you are having some velocity, would not your location change? Won't you move from point A to point B? Where are you moving here? Suppose you are standing at a 10-meter distance. After 5 seconds you are at 10 meters. After 10 seconds you are at 10 meters. Same 10 meters. After 15 seconds you are at 10 meters. You are at the same distance. You're not traveling at all. Actually, I would have liked the language position here. It's a position time graph, strictly speaking. Whose position time graph. That's what I would have liked. So your position is at 10 meter, at 5 seconds, at 10 meter, at 10 seconds, 10 meter at 15 seconds. So where are you having velocity? You are having zero velocity. You are not moving at all. Rest. Any question? Let me know. This question is your assignment question. We stop now.